Courses in the cement industry. Present to you. In this course, we will explain the process. Hard-facing a vertical roller mill. We will discuss in this session typical questions on hard-facing in vertical mills. And with you watching a full video of how hard-facing is done. Hard-facing the wear segments in a vertical mill. Instead of replacing the entire segment, a new surface is welded onto the wear part. Hard-facing gives you shorter downtime, better performance, longer service life, and shorter payback. Hard-facing costs only about a third of changing the wear parts, and can be done in half the time. Long-lasting, flexible, and sustainable wear solution for vertical roller mills. Whether it is lower grinding efficiency, higher energy costs, or increased risk of equipment damage, excessive wear of your vertical roller mill means trouble. But with our in-situ hard-facing services, you can keep that trouble at bay with optimum wear protection for optimum mill performance. Optimal wear protection for highly abrasive grinding conditions. Vertical roller mill components are subject to severe wear. This is particularly true when grinding materials with high silica content and slags, such as are found in cement mills. This wear has a direct impact on a plant's bottom line. A worn vertical roller mill roller reduces grinding efficiency, increasing the energy demand and costs of milling. Excessive wear of the mill lining may also result in increased vibration, exacerbating the problem and risking damage to the equipment. Hard-facing the ATOX and OK vertical roller mills. Hard-facing life is determined by evaluating acceptable levels for maintaining the product fineness, decrease in production, higher pressures, and vibrations. These values are specific to different types of product and mill size. The wear rate on the table has decreased to only a quarter of its former value after hard-facing. Base material for hard-facing. Use high chromium cast irons for the segments. These materials are very wear resistant and well suited to hard-facing. Hard-facing materials. The recommended materials for hard-facing, high chromium cast irons, are welding alloys Integra 100, HCO, and Integra 300, CNO. The latter gives approximately 30% better wear resistance, for a price increase of 30%, thus increasing availability of the mill. It must be understood that when welding with these materials, the resultant bond between base material and hard-facing is not a fusion weld. It is more a kind of cladding, with only sufficient strength to stay onto the base material. Important note: to give a specific wear guarantee, a grinding test is needed. Optimizing equipment. The welding equipment best suited to a certain plant depends largely on the required run factor of the mill and the wear rate. The wear rate for clinker grinding is normally proportional to the specific power draw, kilowatt-hour, per ton. Typical questions on hard-facing in vertical mills. Question 1. What types of wear materials can be hard-faced? The answer: most white cast irons, especially the softer type of white cast irons, like NIHRD 1 to 4. Also CR27 and CR20 for OK mills, and material 364 for ATOX can be hard-faced. Question 2. What type of hard-facing material should I choose? The answer: HCO and CNO. CNO is approximately 30% more wear resistant than HCO. Question 3. Is it necessary to preheat? The answer: no. The temperature should be kept lower than 70 to 808 degrees C, to produce as hard a surface as possible, with a fine carbide structure. When welding at these temperatures, the hard facing cracks continuously, relieving stresses. Question 4. Can segmented wear plates be hard-faced? The answer: both segmented grinding tables and rollers can be hard-faced. In fact, it is safer to hard-face segments than full rings. Rings have a tendency to crack after a number of re-welds. The segmented design is pre-cracked but safely bolted on. Question 5. How much hard-facing material can be put on an hour? The answer: depending on the capacity for heat dissipation, the normal welding parameter settings will allow 5 to 6 kilograms per hour to be deposited on small items, and 8 to 10 kilograms per hour on larger ones. Question 6. How long will it take to hard face my mill? The answer: at Lyman 4.2 tons, took around 3 weeks all included. The time can be cut when the equipment is designed for the specific mill, so that no dismantling of the mill is necessary. Also depends on the maintenance strategy chosen, number of guns, etc. Question 7. How long will the hard facing last? The answer: normally, the wear life is more than double that of the initial cast wear parts. Question 8. Should I start with built-up wear parts? The answer: if the wear pattern is known, and continued operation is essential, pre-welded segments could well be an option. Normally, it is better to determine the maximum wear depth or profile and then start hard facing. Storing hard-faced items can be a problem due to corrosion problems. Question 9. How thickness a layer can be built up per pass? The answer: normally a bead size of about 3 and 8 mm, using a 2.8 wire, and a welding speed of 0.8 to 1 meters per minute. Question 10. What is the maximum layer thickness? The answer: in principle there is no limit, up to 80 mm has been achieved. Typical layers are 20 to 45 mm thickness. Question 11. What are the wear properties? The answer: compared to typical white cast iron wear materials, the lifetime is approximately twice as long. Question 12. How do I distinguish between hard-facing materials? The answer: the higher the carbide content, the more durable it is. Question 13. How many times can I weld table liners? The answer: more than 25 times has been reported for the OK mill table. Question 14. Welding of rollers. The answer: 10 times or more, for segmented mills, has been reported. One concern is distortion, causing loosening segments. No problems reported so far on OK mills. Question 15. How do I inch the mill? The answer: a frequency-regulated motor of around 5 kW drives the gearbox through a chain or belt drive, mounted to the gearbox coupling. The gear pump station must be operated during welding. Question 16. What is price in dollar per kilograms welding? The answer: the price differs from country to country. The price is around $10 per kilograms of welding material. Some offers from vendors indicate a price of $20 per kilograms for the finished welding. Portugal, Germany, and Denmark. Question 17. What is initial investment? The answer. The initial investment for two manipulators, with welding head, power pack, current connection, and a barring device is around $70,000. Question 18. Is there a reliable wear test, taking into account the specific pressures? The answer. Wear is very dependent on specific pressures, iron content, carbide grain sizes, and hardness of ground material. Normal reference is the American Society for Testing and Materials Rubber Will Test. Question 19. What can possibly go wrong? The answer. The segments can distort, and come loose. Grinding rings can crack. The welding current may flow in the wrong direction, burning the bearings. During barring, a Mitchell bearing shoe can run dry. In a coal mill, a fire can start. The hard facing may spall off the parent material. The safest solution is standard cast materials. The need to extend service life of wear parts to match that of the rotary kiln can justify the extra cost and time involved in hard facing. Question 20. Why has it not been offered before? The answer. Only during the last 5 to 10 years has hard facing on roller mills been tested and accepted. Bad experiences with roller press surfacing, due to cracks in the weld deposit, were a major bar to acceptance. Question 21. How do I program the PLC for the regulating equipment? The answer. During commissioning of the equipment, the maintenance personnel will be trained. Question 22. Can a corrugated wear pattern be smoothed out? The answer. The weld deposition rate is adjusted when encountering a hole so as to give a smooth surface with the original pattern. The hard facing seems to prohibit regeneration of the corrugated surface. A different grinding geometry can also be generated, if so wished. Question 23. Can rollers be driven by the grinding table? The answer. Yes, but it is not recommended. The table can be welded first, so as to obtain an even surface to drive the rollers. All rollers can then be welded simultaneously. If possible, rollers should be turned individually during welding. Question 24. Should welding surfaces be cleaned before welding? The answer. It is not necessary to grind the surface before welding. Only cleaning of the grinding bed is needed. On the rollers, the slag falls off by itself. Question 25. How do I mount the manipulators? The answer. The manipulators are mounted on the rollers themselves, or on the housing, whichever is the most stable and convenient. Question 26. How do I control the welding? The answer. The welding is done in automatic mode, to avoid injuries to the eyes of the operators. Question 27. What mill sizes can be welded? The answer. All the OK 25-3 to 36-4 mills can be welded in situ. The ATOX mill range can also be welded in situ, but with the smaller coal mills, it is necessary to take the rollers out first. Question 28. How hard is the hard facing? The answer. The welding is done cold, and the hardness obtained is 60 to 64 hardness on Rockwell scale. Question 29. Can a cracked or broken edge be repaired or gouged? The answer. In theory, this is not possible. However, experience shows that it can be done, the alternative being to scrap the segments anyway. So gouging can be used to remove high points on the grinding track. Watch together this video of the hard facing process for vertical raw mill. Thank you for watching, and I hope these courses are helpful to everyone. Subscribing to this channel Cement Industry Courses would be appreciated. Thank you.